Good afternoon, learners. Today I'm going to present grade 8 mathematics, and we are going to do whole numbers, but we're going to put our focus on multiples and factors. And the person who's going to present, meaning that my name is Maputsi Machechani Alice. Okay, like I indicated, I'm going to, when we deal with multiples and factors, it simply means that in our grade, we're gonna calculate the prime factors, we're gonna calculate the highest common factor, we're gonna calculate the lowest common factor. So before we do that, I just want us to remind ourselves of some keywords. As you can see, in factors, in highest common factor, we have a word factor. And a factor is a number that divides exactly into a whole number without a remainder. So example, let us take 6 as an example. What will be the factors of 6? It could be 1, it could be 2, it could be 3, it could be 6. Why? Because 1 divided by 6 goes 6 times without a remainder. Same applies to 2. It goes 3 times without a remainder. And 3, it goes 2 times without a remainder. 6 goes once without a remainder. But when we deal with highest common factors, we use only prime numbers. But now, what are prime numbers? They are numbers that have only 2 factors, the number itself and 1. For instance, if I'm looking at the prime number of 2, if I'm looking at the prime number of 2, okay? So these are examples of prime numbers. If I look at the prime number of 2, the factors of 2 will be 2 and 1. Factors of 3, same applies, 2 and 1. Factors of 5, 5 and 1, and all those other numbers. Hence we say prime numbers are those numbers that have only 2 factors, that is the number itself and 1. Okay, now what are prime factors? Okay, prime factors are the prime numbers, meaning that when you look for prime factors, you only use numbers from the prime numbers, because prime factors are prime numbers, meaning that you have to start with 2. Then if 2 doesn't divide, then you move to 3 and so on and so on. So usually the question will be, generally you'll be asked the question like, find the prime factors of 210 and 130. Okay, there are many methods we can use to do this, but today, because of time, we're just going to use the ladder. So how is that one done? Okay, a ladder, you have to draw a ladder, then you start putting the number that you are looking for, the prime factors of it. So that now, like I indicated, you only use the prime numbers. Don't forget, our prime number starts with 2. So now we're going to start with 2. So 2 goes how many times into 210? So the answer will be 105. Okay, but because of the last number, I can't divide by 2 anymore. It means I have to move to the next prime factor, which is 3. So now we divide by 3. 3 into 105 goes how many times? It goes 35 times. And also because of 5, 3 cannot divide. So we move to the next one, which is 5. 5 goes how many times into 35? Then it goes 7 times. So the next prime number should be 7 because 7 only divides into 7 and it goes once, as you can see. Okay, those are the prime factors. So the prime factors of 210 will be 2 times 2, 3 times 5 times 7. So those are the prime factors of that. 5 times 7. So those will be the prime factors of 210. So now let's look at the prime factors of 130. 2 divided into 130, as you can see, it goes how many times? 65 times. Then because of the last number 5, 2 cannot divide, then we move to the next prime factor. In this case, it's 5 because even 3 cannot divide. So 5 into 65 goes how many times? 13 times. Then the next prime factor will be 13. 13 into 13 goes how many times? Once. So now you have to list the prime factors of 130, which will be 2 times 5 times 13. So those are the prime factors of 130. So now let's go to finding the HCF of 210. So for us to find the HCF of 210, I just use the same numbers so that we can save time. You have seen how to find the factors. You start dividing by the smallest prime number. Then if it doesn't divide, then you go to the next one up till you get them correct. So now I'm just going to list the prime factors of 210, which is 2 times 3 times 5 times 7, and also list the prime factors of 130, which is 2 times 5 times 13. And to do this in an easier way, try to put the same prime factors below each other so that you can see those that are common. So now, how are we going to find the prime factors? So now check what we're gonna do. Can you see in both 210 and 130, there is 2 which is common. And for the 2 2s, we're just going to write 1 2 because it is common to both. Also 5 is common. So our highest common factor, what is it going to be? It's going to be 2 because it is common to both lists, times 5 because 5 is common to both lists, meaning that when you look for the highest common factor, what you have to do is you have to take the common number only. In this case, it is 2 and 5. So now we multiply the 2. Finally, our highest common factor will be 10. So now let's move to the lowest common multiple. Okay, now let's look at the keywords that we're going to come across. We're going to come across the multiple, but now what is a multiple? We talked of a factor, meaning that a factor is that number that divides into a number. So now what is a multiple? It is the product of 2 natural numbers. Okay, now let's see examples of multiples of 9. Multiples of 9 will be 9. If I multiply 9 by 1 is 9 by 2 is 18, 27, 36, 45, and 54 up to infinity. So those are the multiples of 9. But now, if you look for the lowest common multiple, what are you looking for? For the lowest common multiple is when one number is a multiple of 2 or more different numbers. In our case, like you're gonna see, we're gonna use 2 numbers, 210 and 130. Okay, I'm using the very same numbers, 210 and 130, so that you can see the difference between highest common multiple and determining the lowest common multiple. So as we did with the highest common multiple, those are the prime factors of 210, which will be 2 times 3 times 5 times 7. Then let's look for the prime factors of 130, which is 2 times 5 times 13. Like I indicated, try to put the common prime factors below each other so that you can be able to group them. Because as you have seen with the prime highest common factor, the factors that appear in both lists, that occur in both lists, must be taken once. So let's look at this one. As you can see, we have 2 in 210, and we have also 2 in 130. So we group 2 for, and also we have 5. They appear both in those two lists. So for us to find the LCM for the 2 2s, we only write 2, but we have also to multiply by 3. Okay, we multiply by 5. For the 2 5s, we only take 1 5. We multiply by 7, and we also multiply by 13. So what did we do here? What we did is that all the numbers, to find the LCM, you write all the prime factors, but those that repeats, you write them once. Like in the case of 2, 2 repeated, I wrote it once. 3 doesn't appear, so I write it there. 5 repeats, it has to be written once. Then you still have to write 7, you still have to write 13. So in case of the LCM, after listing them, then all the numbers should be written down, but those that repeat has to be written once. So now finally you have to multiply all those numbers. So your answer will be 2,730. So this one will be your lowest common multiple. So let's go back a little bit. Let's go back a little bit. Okay, let us go to slide number, the previous slide. I just wanted to show you the difference between what we are doing here. Highest common factor, what did we do? We used any method. In this case, we used the ladder to find the prime factors of those two numbers, and we listed them. After listing them, to find the highest common factor, because the highest common factor is the factor that is in a set of numbers that those two sets of numbers have in common. Highest common factor is the factor that the two numbers 210 and 130 have in common. So which are those numbers? In this case, it was 2 and 5. So to find the highest common factor, you must multiply those two numbers that were common, and you got 10. So now let's try to check what happened in LCM. In LCM, we are wrapping up. In LCM, you list the prime factors, finding them from any method, even a calculator you can use. So after finding them, all the numbers has to be written, but those that appear twice, because I'm having two lists of numbers, you write them once. So in our case, what do we have? We have 2 times 3 times 5 times 7 times 13, meaning that we did not leave any number behind, as in the case of highest common factor. So from there, you multiply all those numbers, and the answer is there. So I'm sure now you understood the difference between the highest common factor and the lowest common factor. In the highest common factor, you only take those numbers that appear. You only take those numbers that appear in both lists, then you multiply them. But in our highest common factor, you multiply every number that appears in list 1 and list 2, all those prime numbers, then you multiply them together, taking into cognizance that those that appear, you only write them once. In this case, we have 2 and 5. So it is 210. So now we have come to the end of our session. And I would like to thank you very much for tuning in or for logging in. So thank you very much. Thank you very much. So this is slide 7 of 7. So thank you very much. But because before you log off, make sure that I'm going to send you the QR code where you have the multiple choice of things that we did today. So please make it a point that you complete them today. Why today? So that at least today, I just present to you LCM and HCF. So it's still fresh in your mind, so it will be easy for you to calculate them. Thank you very much. See you next time, which is tomorrow, because I'm going to have another presentation tomorrow. Thank you very much. Thank you.